for one, reviewing this common system will help us because it goes right into what we're going to do, the very first part of our notes. The other thing, too, is that everybody is struggling with this. And this is a first 6 weeks concept. So we're going to do this first. First thing we're going to do is find this particular question. It was on your review, and it asked us to find the answer to the system of equations. Now, in order to do that, there's several different things you can do. But the one way we're going to do it is we're going to kind of do it the long way because everybody's struggling. I want you to put your calculators down. I don't want you to use your calculator. Because those of you guys who are going into pre-AP need to start not being so reliant on your calculator, first of all. Those of you guys who are just trying to get past this class and go to the next class, usually the calculator is fine until they start asking you how you got the answer. So some of you need to stop being so reliant on the calculator and be able to do this with paper and pencil. And realistically, it's sometimes easier to do it with paper and pencil than it is a calculator. But you guys are just kind of lazy. You don't want to write. It's not that you can't. It's just you choose not to. So anyhow, what we got to do is, in order to solve this system of equations, the first thing I want to do is create two equations. These tables will represent two equations. And up to this point, all you know they're going to represent is either A, a linear, or B, a quadratic. Okay, the way I'm going to figure that out is the first thing I'm going to do is I'm going to check to make sure it's linear. The way I'm going to do that is I'm going to look at my y column. How do I go from 13 to 11? So plus 2. How do I go from 11 to 9? And then 9 to 3, you add 6. But I also have a jump from here, from 0 to 3 of what? 3. And then from here to here is what? So plus 3 here, plus 1 here. Okay, so in any case, you have a very consistent, it's jumping consistently at a constant rate. Okay, that's how you find your slope. If you remember, first 6 weeks, that's how we found our slope. So how do I find the slope of that first one? No, I'm not going to do y1 minus y, whatever. I'm not going to do that. It's too... Yeah, change in y over change in x is so much easier than trying to put it into a coordinate or a slope formula. So my slope would be, what is my change in y? 2 over, what's my change in x? 1. So the slope for that first equation is 2. Now, I'm going to continue on. In order to solve this, I need to put this into y equals mx plus b form. Okay, so I need the b now, because right now I have y equals 2x. Now I need the b, which is your y-intercept. Okay, what is my y-intercept in that first table? Negative 9. How do I know that? Because x is 0, so it's minus 9. In order for you to have found this in your calculator, you would have had to sit there and go, stat, edit, -2, -1, 0, 5, crap, I screwed up, arrow up, back down, 3, over, -3, -11, -9, -3. Second quit, stat, calc, linear regression, 4, 3, whatever the number is, enter. And then you had to write it all down. I could have just solved that, but you guys are so lazy sometimes that you just want to use a calculator for everything. Guys, calculators are only as good as you are. And that's what I think people forget is I use my calculator. I shouldn't have got it wrong. You're the one punching the buttons in the calculator. This is quicker than all that stat edit garbage. I don't like that. I can't stand it. This is the first year I've really ever taught it to anybody. And this is why. Because all you guys want to do now is work on that. When students come to me and say, well, how do I stick in the calculator? Well, I've taught you that already. Why don't you not use a calculator? Let's do it by hand. I won't remember how to do it. This is math. Calculator isn't. Okay? It's a tool, yes, but that's not learning math. Okay, so we found the equation for the first one. Now let's find the equation for the second one. Okay? So again, I've got to do the same thing. What's my change in y? -3. What's my change in x? +1. So my slope is still found the same way. M equals change in y over change in x. So M equals what? -3 over 1. So M equals? -3. my equation for this one is a little more challenging to find, and this is what throws you guys, and you want to give up, assuming you started to begin with. Now you have y equals negative 3x. We still have to find that b, that dreaded b value. What's our y-intercept in this one?
Negative 6.
Okay? Negative 6, no.
Negative 9.
Okay? Now here's the deal. The reason I'm asking that question is, can you find it from the table?
No.
No. You cannot find it from the table. So what am I going to do in order to find my b?
You're going to add, once you add 3 to the x, you're going to set 0. And then
Well, you can't add.
Okay, so look, she's actually got a valid point. You could do this. She said, here when we went from 2 to 3, we added 1. So if I go back 1, if I subtract 1, I get what x value? 1. If I go back this direction, what am I going to do? Add 3.
Oh, yeah. So it's 6. 3. 3. It'd be 0 and 6.
Well, I can't write there. So I'm going to add 3. So then I have 1 and 3. So if I go back up again, I'm going to end up with 0, because 1 minus 1 is 0, and 3 plus 3 is 6. Okay, so that's how I would get that. That's one way to do it. Now, it's not always that easy. And that's a great thing to find. Now, Algebra 1, generally, it's going to be that easy. But there's other resources that you already know how to do in order to find the y-intercept. What is that? What? Yeah, what I would do is I would say, okay, I have a y value. Let's just go with 0. My y value is 0. I figured out my slope was negative 3. If my y value is 0, what is my x value? 2. Okay, and I don't know b. But now can I solve for b? Yes, 0 equals negative 3 times 2 is negative 6 plus b. Now what? Add 6 to both sides. So now I have 6 equals b. So it's the same thing that she got, right? Not bad. That's easy. The other thing you could use, which I'm not a big fan of, but you can use it, and I have taught it to you, is what? Point slope. No, not the calculator. Point slope. The whole point of this is not to use a calculator. Point slope. You could have done the same thing by plugging in y minus y1 equals x times x minus, or m times x minus x1. So you could use point slope. Yes?
I'm confused with what you did there. The 0, is that?
This is a point from the table that was given to us. This is a y value, because remember, in y equals mx plus b, y and x are just coordinates that are on the line. So this is a point, this is a y value, this is my x value. I just plugged it in and solved for b. Okay? And so now my equation for this is y equals 3, negative 3x plus 6. Now, the biggest thing I want you to see is how to solve that, or how to write the equation. Because solving it isn't that bad. Okay, but again, if you aren't going to use your calculator, one, I know this is a crazy thought, but you could actually plot points on an actual graph and actually draw a straight line and another straight line on paper and actually see where they cross. That's a great thing to do too. Because a lot of people don't remember that in the calculator when you put it in there and you look, some people are like trying to arrow over and it's so minor, it's so tiny, you're just trying to guess. Instead of hitting second trace 5, enter, 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 to get the actual intersection. But the other thing you can do, because I don't like to graph, and I'm sure you don't like to graph, is you can solve this two ways by the way it's written right there. Number one, I can solve it by substitution. If I wanted to solve it by substitution, I would simply replace this with y, because I know that y equals this. And since y equals this, I can just plug that in over here. Or I could say, well, let me take this one and put it over here. Either way, it's the same. That's called setting them equal to one another. I'm going to set them equal to each other, and so then I'm going to solve. 2x minus 9 equals negative 3x plus 6. Go back to doing a little review. Okay? I'm going to add 3 to both sides. This is going to be 5x minus 9 equals 6. Now what? Add 9 to both sides. 5x equals 15. And then x equals 3, because I'm going to divide both sides by 5. It's over there behind the hand. Okay, x equals 3. Once I get x equals 3, I just plug it back in here. Solve for y. So 2 times negative 6 is, 2 times negative 3 is negative 6. Negative 6 minus 9 is negative 15. So my solution should be negative 3 comma negative 15. Okay, if you don't like substitution, and that doesn't work for you, well, forget it. Let's get rid of substitution, because that's essentially what we did. Now, I'm going to erase this up here to give me some more room so we can see it actually. In the systems of equations unit, we said that if it's set equal to y, like in this situation right here, the best method is graphic. I just showed you how to substitute, and the best way to do elimination was if they were already in standard form, right? I can solve this using elimination just the way they are. You don't have to be in standard form to do elimination. You just have to have the variables lined up. That's really the key. So here, I have the variables lined up, right? Are all the variables in the right order?
Yep.
Yeah, let's use elimination in this form. What can I eliminate very easily?
The y.
The y. How do I eliminate the y?
Multiply by -1.
He said multiply the top one by -1. I could have multiplied either one of them by -1, but the top one's fine. So when I do that, I end up with negative y equals negative 2x plus 9.
Wait, that'd be positive. Oh, wait, okay, equals looks like negative.
So then I'm going to bring this one down, and I'm going to have y equals negative 3x plus 6. I didn't do anything with that one, right? Now, I'm going to solve by elimination. Negative y plus y is 0. Negative 3 minus 3 is negative 5x. Just adding, right? So 9 plus 6 is plus 15. Okay, so
Subtract 15. You solve
subtract 15. Equals negative 5. Divide both sides by negative 5x. 3. Oh, should this one be positive 3 on the other one?
Yeah.
Oh, I wrote negative on accident. Sorry. I was throwing myself off because I threw it negative. Okay, so x equals 3. Once I solve that, all I got to do is plug it back into one of the originals. Okay? And then when I solve that, I end up with, and this shouldn't have been negative 15. Because 2 times 3 is 6. 6 minus 9 is negative 3. So then I go back up here. Let's just plug it into y equals negative 3x. So negative times 3 times 3 plus 6. So negative 9 plus 6, y equals negative 3. So I get the same answer. So that's how you do it on paper and pencil. And again, we did it 2 different ways, so it looks like a lot more work than it really is, but please know how to do that. If you don't know how to do that, you don't know math. I'm just telling you right now, especially you guys going to the pre-AP route, some of you guys there'll be tests where you do not get a calculator. You cannot be solely reliant on a calculator. Nobody in the world walks around with a calculator like this in their pocket. Okay, I'm sorry, they don't. Okay, just know how to do this. It's not that hard. All right, with that being said, let's look at our first example on our new notes. Okay, so you have 2 graphs here. Let's go ahead and just figure out the slope real quick. Let's take a look at each one.
It's the same graph. Yeah.
No, it's not. Okay, the last one, the y-intercept was 0 and 6.
No, both those graphs are the same.
Yeah, I said let's figure out the slope of the graphs. Okay, 1 to 2 is plus 1, right? 0 to 1 is plus 1. 2 to 4 is 1 to 2 is 2 to 3 is Okay, and on the other side, 4 to 8 is plus 4 plus 1 on this side plus 8, right? Now here's the problem, okay? Here's the problem that you face. If you have all 1s on the left and your numbers are not the same on your right, can I find the slope? No, I cannot. Okay? So they are not a constant rate of change.
Wait, but that would be an equation though, because it's just multiplying by 2 every single time.
Okay, yes, but this is a new type of equation, which is what we're talking about. Because if you look at the top, it's exponential functions now versus linear. It's not a linear function. You can't just go y equals, well, 2 times the slope. It doesn't work like that. Okay? So what happens is, you now know because of this change, it's not a constant rate of change. That's what slope is. Constant rate of change. Well, this is not constant. This is changing by 2. This is changing by 4. Okay? And you said multiply by 2. But you could also look at this as an increase of 2. For some people, an increase of adding 2, adding 4, and so forth. Because that's what I heard a lot of. Okay? Now, in any case, exponential functions, that's what goes in the blank here, involve repetitive multiplication rather than repetitive multiplication rather than addition. Okay, we were doing addition earlier, but now you're doing multiplication, a repetitive multiplication rather than addition, which is like linear functions, right? So exponential functions are repetitive multiplication. So for those of you guys who are looking at it in the terms of adding 2, adding 4, so on, that would be a linear. When you multiply by 2 each time, that is exponential. Oh, I can't spell. Well, I can't really spell it all. Exponential. There we go. Huh? Oh, that's not linear. See, I was all trying to write the wrong word anyways.
And I don't even know why you're doing that. It's right in front of your face. It's right above you.
Well, I just was. Alright. So here's what we want to do. I want to sketch the graphs of these following things. So in your calculator, okay, we're going to use our calculator just to do a quick sketch of the graph for time purposes. But go ahead and hit y equals, because all we're doing is comparing. That's why we're using our calculator here. So hit y equals. Okay, in the calculator, hit y equals. And then go ahead and put 2. To raise something to an exponent unknown, you would hit the little caret button or the rooftop. Some people used to call it caret. I'm not sure why. I call it the rooftop button. Hit that button and then put x up there. Hit graph. And if your window's crazy, hit zoom 6.
Wait, what?
So on your paper, draw a little sketch of that graph. You actually have to do it to see it. Okay, now hit y equals and graph 3 to the negative x. 3 to the negative x. So y equals 3 rooftop negative x. Graph. Sketch that graph. Moving on. Okay, if the exponent is positive, then we say It is exponential growth. Because which direction do you think it goes? Okay, it goes up, right? It's growing. You grow up, not down, right? Well, some of you grow up. Anyhow. So, which of those three graphs that you just graphed is exponential growth?
The first two x.
Yeah, 2 to the x.
2 to the x and 1/4.
2 to the x and 1/4 to the x. Okay?
Did anybody else get one?
Let me look at 1/4.
Yeah, no.
Yeah.
This is.
Okay, is 1/4 to the x growth?
No.
Yeah?
No. I'm looking at Angelica's. I looked at her. You did this one wrong.
I got the
That's what I got.
2x.
That's because you did 4/1.
Oh, whoops.
Yeah. Okay. So, when the exponent is negative, then the exponential is, what's the opposite of growth?
Shrinking.
Okay, kind of. It's scientifically. Think scientifically.
Decreasing.
Okay? It starts with a D.
Minimizing. Diminishing.
What happens to your body as it lays dead in a ditch?
Oh my gosh!
It's kind of morbid, huh? Decay. It does decompose, you're absolutely right, but it also decays. Okay? So it's called exponential decay.
I don't want to die.
I should have said what happens to your body when you're dead and you're in a coffin.
And you're already dead.
You're already dead, so I implied that you were murdered. So,
You're gonna get yours.
my mistake. My mistake.
So,
Or you fell over and hit your head on accident. I mean, that happens. Just walking.
Okay,
Yes.
let's get out of this
I'm
conversation.
curious on what graphs are growth and which ones are.
So growth, from left to right, go which direction?
left or right?
Oh.
Growth from left to right, go which direction?
Oh,
Yeah. Up. Growth from right to, graphs from right to left, they go,
wait, so
down.
the first one is growth.
yeah, we said that.
Wait, but
Oh, wait, so the first and the last
1/4 is
one.
positive.
Okay.
How is
because
1/4
That's why I was confused.
Hey, let's get there. Okay? Yes.
It's like a roller coaster, like this goes up and then that goes down.
Right. So if it's going up from left to right, it's growth.
Unless you're writing
If
Mr.
it's going
Freeze.
down from left to right, it's decay. Now,
What about the Mr. Freeze range?
okay, hey, we need to keep moving. We're running out of time and I'm not going over extra time on this. Okay? Alright, now, what graphs are decayed?
Second and third one.
The second and third one. Okay? The second and third one. Now, somebody asked, why is the fourth one? Because it says if the exponent is negative, then it's exponential decay. And so on the second graph, the exponent is negative, right? On the first graph, the exponent is not negative. So the third one, the exponent is not negative. So why is it decay then? Because it's a fraction. And the thing about it is you could have changed it to a negative, and it would have been a whole number. A whole number. Whole number would have been negative. Remember our exponential laws? We have negative, we flip them.
Yeah.
So if it's a positive, so essentially what this is y to the 1/4 x is the same thing as y to the, okay, y equals 4 to the negative x. It's really the same graph. So really quickly on your calculator, I want you to graph in y equals 1, the first line, y equals 1/4 to the x power. And then in the second line, I want you to graph y equals 4 to the negative x power and see what the graphs look like.
Wait, what was the second one?
First one is C, the third graph.
Divided by what?
So the first one is y equals 1 divided by 4 to the x power. Okay, and then the y2 equals 4 to the negative x power.
Oh, wait, no, this is not.
Same graph.
Yeah.
It's inverted.
It's the same.
Whoops. I'm working on it right now. You are so impatient.
It looks like we're
like hands too?
No, it's not when they're crawling on me.
Wow.
Okay.
So you have some hateful. Yes.
It's 4 to the negative x power.
Oh, okay.
Okay, they're the same graph, right? So that's why a fraction is going to be a negative a decay. A fraction is going to be decay. So then, the last part of this says when the base is between 0 and what?
1.
1, what does that make it?
Okay.
It's exponential decay, but what is that number?
It's a fraction.
It's a fraction. So y equals bx is where the b is the common ration and the variable is the exponent. Oop. Okay, so now we're going to determine if the table represents an exponential function. And if so, oh, you can't see it, sorry. Okay, if so, what is the common ratio? Okay, so let's determine if it's an exponential function. Okay, so the first one, 0 to 1, 1 to 2, and 2 to 3. So they're all 1s. Now let's look at the other side. 10 to 13 is plus 3. 13 to 16 is plus 3. 16 to 19 is plus 3. So what is this? Linear. What kind of slope do I have?
3.
Okay, so my slope is 3. Let's look at the next one. 1 to 2 is 1. 2 to 3 is 1. 6 to 8 is 2. 8 to 12 is 4. What is this one? Exponential. And what can you tell me about this exponential?
That it's
Positive.
What's the common ratio?
What is the
2.
Okay, here's the common ratio. Here's how it works. Okay, here's how you figure out the common ratio. That's what we skipped over earlier, sorry. Common ratio is figured out like this. You go 8 over 12. No, 12 over 8, excuse me. 12 over 8 equals what when I reduce it? 4 thirds. Okay?
3 over 2, actually.
Yeah, 3 over 2.
Okay, and then I do 8 over 6. Whoa. What's 8 over 6?
Is 4 over 3.
Oh, you know what? Sorry. Sorry.
How'd you even expect us to learn this?
Okay, we don't have time for that. Listen, there's a mistake on the notes.
Man, Coach, where did you get these?
Okay, these numbers are wrong. So fix these numbers to 9, 12, and 16. Okay. Now, we already said 1 to 1 on the other side, so this side is what? Plus 3. This side is plus 4. Okay, so there's where you lose your common, right?
Yeah.
So now, the way you find your common ratio is you take 16 over 12. And you get what?
4 over 3.
4 over 3. Then you take 12 over 9. And you get
4 over 3.
4 over 3. So my common ratio, what do you think is what?
4 over 3.
So when you do an exponential, once you've determined it's exponential, then you just take the last number and go to the very next one. And to the next one. And to the next one. Assuming that you're not skipping any numbers on the left side. Okay? Yes?
so we choose this tape, so since it's plus 3 and plus 4 on the right side, the one to this side, put a number and then on the side.
I'm sorry, you're going to have to speak a little bit louder and what?
Like, since that one's 4, since you're adding 3 and adding 4,
You're on time.
and then wouldn't you just put that into a fraction?
No. Because what's the next number going to be? What's 4 going to be?
20.
Okay? Would it be 20?
Yeah.
21. Okay, because what's 21?
Oh, that's plus 5.
And then it's gonna be 27.
Okay, so yeah, it's not going to be quite like that. It's not like slope, okay? Yes.
So the linear graph, you would just forget about it, like you wouldn't do anything with it? Like there's a linear and exponential.
These are two separate problems.
Okay, so you would just leave the linear out of it?
That's not relevant to this at all. Linear, they're not going.
Yeah, that is. Because
Two
it's
separate problems. We just figured out this was linear. Done. Problem over. We said, what's the slope? Slope was 3. Problem over. Moving on to the second problem. They're not together. So we're just figuring out this is exponential.
So the answer is 4/3.
So the common ratio is 4/3. Yes. Okay, moving on. You understand now?
Yeah.
There were two separate problems. Okay, so now let's complete the table and graph it. Okay, so we have y equals bx. So if x is 0, base to 0 is what?
0.
Anything to 0 is what?
Wait, that'd be your base.
1. So y is 1. Okay?
Wait, why would it be 0 though? Because x would be noticed. Why would it not be 0?
Why would what be 0?
Why would x be 0 if...
Because it's in that table that says x is 0.
Oh, okay.
Huh? Yeah, now, in order to solve this, we can't have bx. We're going to have to change this to a number. So let's go with y equals 3 to the x power. The first one we can solve because anything to the 0 power is what? 1. So now I'm making this 3. So your base is 3. So now y, when you have 3 to the first power, is what? 3. Y, when you have 3 to the second power, is 9. Y equals 3 to the third power, you have 27. Y equals 3 to the fourth power, you have 81. Y equals 3 to the fifth power, you have 243.
Why'd you pick 3?
Just because.
Does it not matter? You just randomly.
No. This, the problem. This is just a problem. Sometimes you'll be given y equals 4 to the x power or 87 to the x power. It's just a problem. I just picked the problem. I couldn't have solved. We couldn't have figured out what b to the third power is unless we had a number there, right? So I just picked 3 to put that number in there. It was just an example. Now let's graph it. All right, so when I graph this, I'm going to go 0 and 1. 0 over, 1 up. Then I'm going to go 1 over, 3 up. Then I'm going to go 2 over, 9 up. Okay, 3 over, I can't go any further, right? Can I go 27 up? No. Can I go 81 up? No. So the answer would be no, okay? So I draw my line here. It's going to look like that. So do we have positive? It's positive, so it's called what? Exponential growth. I knew it was going to be exponential growth because why?
Y's were increasing.
Well, first of all, there was no negative. That's absolutely true.
Exponential.
I know, that's why I answered you. Good job. But I also knew, because not specifically that there was no negative, but what was not negative?
It was increasing.
No, I'm talking about from the beginning. The x was positive, and the number, the base number, because this is your b for base, the base number is what?
More than 1.
More than 1. Very good. Okay? What's my domain? What's my domain? All the x values. Now, let me give you a hint that was not put on these notes. Exponential functions will never cross the x-axis. Never cross the x-axis. That means x will never be... I'm sorry. You'll never have a y that is what?
Negative.
Negative. Thank you. Okay, now, with that being said, what are all our x values? And somebody already said it. All real numbers. Because as I continue to go up, I'm spreading out, right? So I'm going to cover all my x values. So it's all real numbers. The range is what? All positive. How do I write that?
It would be greater than 0.
So y is greater than 0. And it's not equal to 0 because y will never cross the x-axis into the negative y's.
Yeah.
All right? Last but not least, on the last one, all you have to do to solve it is, first of all, are these increasing? So it should be what?
It's D.
It's D.
It's D because it was the last problem. Just listen to me as we rationalize through it. But are the numbers increasing?
Yes.
So this is going to be what? Growth. Thank you. So growth means I'm going to eliminate what? The negative and the fraction. Okay, now,
And then
what is C?
that's
Quadratic. That's gone. What's wrong with E?
it's -3.
But the base, what's going to happen to that negative? It's going to flip it. So that's not going to be it because it's not going to be flipped. These are all going up. So D is our answer. Yes.